and welcome. These are the solutions to quiz 7. Number 1, which value should be reported with 3 sig figs? A should be, because the result should go to the tens place and ends up being 12.9. B does not, because it ends up being 11.00 with 4 sig figs when we round to the hundredths place. And then C also rounds to the hundredths place, goes above 10, so it ends up being 10.xx out to the hundredths place for 4 sig figs as well. So only A goes to 3 sig figs. Okay, for number 2, there's a correction here. If you had seen the original version, we need to convert this to milliliters. So the number of milliliters, and the only conversion factor I'm thinking here is 1 cubic centimeter is a milliliter. It's my main conversion. I'm also thinking 100 centimeters is a meter as well to get me there. So I start with a 5.75 times 10 to the 3 cubic meters. I just use a meter. 1 meter is 100 centimeters. Cube that factor, and then use the cubic centimeter. Is a milliliter. And so that works out to be 5.75 times 10 to the 9. The proper number of sig figs, what is the density of an object that displaces water by a certain quantity? So this would just be 3.2567 grams divided by the volume of the object, which would be 2.67 milliliters. So 3 sig figs on the volume. So the result should have 3 sig figs here. And so I don't even need to do the calculation because we're really just picking the sig figs here. So 3 sig figs on the result. How many sig figs does this value have? We have 5.75 grams per milliliter plus 2 masses added together. Key is this here ends up being equal to 120 with 3 sig fig grams divide by 12.5. We're going to keep all 3 sig figs, add that to 5.75 grams per milliliter. So 120 divided by 12.5. It's 9.60. For 3 sig figs, ends in the hundredths place. We do the arithmetic here, add to the hundredths place, and ends up being if I can put it into the calculator correctly, ends up being 15.35. To the hundredths placeholder, because we look at the placeholder when we do the arithmetic, hundredths place in each of them. So that's what we got to this placeholder. Then we note 4 sig figs in the value. 5. Likely for a similar reason to why a particle is easily exchanged among atoms to make ions. Which subatomic particle was the first to be discovered? Okay, so that's the electron. Electron was the first to be discovered early 1900s, or actually the late 1800s, and the proton and the neutron later in the 1900s. Proton, neutron, electron count for potassium 40. So that's K, 40. Potassium's atomic number is 19. We got to look at a periodic table to get this number. It's the atomic number. So we have 21 neutrons, 19 protons, and then the neutral atom. So for total, just the atom, no charge, has the equal number of electrons for 19 electrons. So that looks like C. Which ion contains the most electrons? Calcium, 2 plus. Chloride is Cl minus. Sulfide is S2 minus. These all actually have that noble gas count of argon of 18 electrons. So they're all isoelectronic, meaning they have the same number of electrons. Some elements such as iodine exist naturally as one isotope, which is found in nature. For iodine is iodine-127. What is the atomic weight of this isotope? I'll just go to the periodic table and look at the mass of iodine. And if you look at the mass listed for iodine, it's 126.904. Depending on the periodic table, you might get a few more digits. Which ion has a total of 56 protons and 54 electrons? So we just go to element number 54. That's barium. And losing 2 electrons from its neutral count will give it a 2 plus charge. Which measurement below contains the most significant figures? So we have 3 here, 6, 3, 5. So it looks like B. Alright, that's all for this video.